Welcome to Compound Inequalities. Today we'll be discussing how to find the intersection and union of sets, and also how to express compound inequalities graphically and using interval notation. Let's start off by talking about the intersection of sets. The intersection of two sets, A and B, is the set of all elements that are contained in both A and B. So if set A consists of the numbers from 1 through 7 listed here and also in the blue region, and set B consists of the integers from 5 to 10 listed here and also in the yellow region, the intersection or the numbers that are in both sets would be 5, 6, 7. Now when we talk about inequalities, when two or more inequalities are joined by and, it is called a conjunction. And when we talk about inequalities connected by and, we're looking for when they will both be true. Now when we talk about the union of sets, the union of sets A and B is the set of all elements that are contained in either A or B. So again, if we have the same set A and the same set B, if we want the union, we want all numbers that are in either set A or B, so the numbers 1 through 10. Again, when we talk about inequalities being joined by the word or, it is called a disjunction, but or would mean when either inequality is true. So there's a big difference when we're talking about the meaning of and or mathematically. Here's another way to think of it. Let's say you're given the statement, you will be happy in life if you make a lot of money and you have a rewarding personal life. In this case, both must be true to be happy. However, if you're given the statement, you will be happy in life if you make a lot of money or have a rewarding personal life, well, in this case, only one has to be true in order to be happy. So let's kind of see how this applies to inequalities. These problems here are examples of compound inequalities. We have more than one inequality, and in each case, they'll be connected by either or and. And our goal here is to graph and write the interval notation for each compound inequality. Now sometimes you're given a compound inequality in this form, and this form will always be an and, meaning both of these have to be true. If we wanted to, we could actually rewrite this as two inequalities connected by and you can read this inequality from right to left, so x would be greater than -2, and we can also read it from left to right, x also has to be less than 5. So what we want to know is what values of x will these both be true? So let's graph them and see what we have. So first x is greater than -2, so it would be an open circle on -2 because -2 is not a solution to this, and we would graph to the right. And x also has to be less than 5. An open circle on 5, but this time the arrow would go to the left, or we would graph to the left. So the question is, where are these both true? And we can see that it's double graphed, if you can think of it that way, between -2 and +5. So this would be the intersection of the two inequalities. And using interval notation, we could rewrite this as the open interval from -2 to +5. Now you can see why they like to use this notation. You can see that x is sandwiched between -2 and 5, which looks just like our resulting graph. Let's take a look at number 2. Now we have the word or, so we are going to want to know where x is contained in either of these inequalities. So let's first graph x as less than or equal to -2. This would be a closed point on -2 and an arrow to the left because it says less than or equal to. Or x is greater than or equal to 3. Closed point on 3 and arrow to the right. Now here, because it's or, we're not looking for an intersection. We want the union of these two, and this graph does already represent the union of these two. However, to write this using interval notation, we should recognize that this is approaching positive infinity. This one is approaching negative infinity. So using interval notation, this interval would be from negative infinity to -2, and it includes -2, so we use a bracket. The second interval would be from 3 to positive infinity. Again, it includes 3. And for the word or, which means union, we use a large U to represent the union of these two sets. Let's take a look at a couple more. Here we do see the word and. We want to know when both of these are true, so we'll graph them and then analyze. X is greater than 5, open on 5 and arrow to the right. Next, X is less than or equal to -1, close point on -1 and an arrow to the left this time. But we want to know when they are both true or which numbers are double graphed, and there are no numbers on the number line that are double graphed or where they're both true, so this compound inequality has no solution. This can also be indicated by what's called the empty set. There are no elements that are in both sets. Let's take a look at another. X is less than or equal to 4, closed on 4, arrow to the left, or X is greater than 0, an arrow to the right. Now it's extremely important we recognize the meaning of this word or. We want to know which numbers have been graphed using this inequality or this inequality, or which numbers have been graphed at least once. And if you take a look at this, all numbers have been graphed at least once. Therefore, we would state this compound inequality would be all real numbers. So graphically, we would just graph the entire number line from positive infinity to negative infinity, and our interval notation would be the same from negative infinity to positive infinity. So as you can see, it's extremely important that we recognize the meaning of the word and or. That's pretty much the main idea. Now what can happen is our compound inequalities can become a little more involved, meaning they may not be solved for x. So if we take a look at this problem, the first thing we should recognize is this will be an and, meaning we want to know when both inequalities will be true. A nice, quick, easy way to solve this for x would be to subtract 2 in the middle, on the right, and also on the left. When we do this, we would have x isolated. We have less than or equal to 2. We'd also have x greater than -7. Because of this notation, let's go ahead and just graph our solution. Reading this from right to left, we know x is greater than -7, so we'd have an open circle and graph to the right. And then we also know that x has to be less than or equal to 2, so we'd have that over here, a close point. And since this would be graphed to the left, and we know we're looking for the intersection, we'll go ahead and just connect these two together. So the set of numbers that are true for both inequalities would be the region between the two. So using our interval notation, we would have from -7 to +2, it's closed on 2, and open on -7. Let's see if we have time for a couple more. Again, you can see this is pretty much the same idea. It's an or, but these inequalities are not solved for x. So let's do that first. We'll subtract 3 on both sides. We'll have 2x less than -5, divide by 2. We have x is less than 2.5. And on this one, we just have to add 1 on both sides. We have x is greater than or equal to 3. So as long as an interval is graphed once, it will be a part of the solution. X is less than 2.5 would look like this. X is greater than or equal to 3 would look like this. Because it's an or, all numbers in this interval or all numbers in this interval would be considered part of the solution. So that is the graph of our solution. So using interval notation, we're going to have 2 intervals. And we could put the word or in here, or we can also use a U for union. So the last example, the first step is to solve both of these for x. So here we'll subtract 2 on both sides, divide by -2. Now remember, when you divide by -2, we do have to reverse the inequality symbol. So here we're going to have positive x is greater than or equal to -2. I like to go ahead and switch this around. Notice how the inequality is still opening toward the x, but for me this is easier to interpret. In the second inequality, we'll subtract 1 on both sides, divide by 3, connected by and. So again, we're looking where these are both true at the same time. We have x is greater than or equal to -2, and we have x is less than 8/3. Since this is and, we're looking for the region that is graphed twice, which would be between -2 and 8/3. This would be the graph, and using interval notation, we'd have a bracket for -2 and a rounded parenthesis for 8/3. I hope you found this discussion on compound inequalities helpful.